Guys, I'm Sudhantra from Gettobyte, and in this video, first we'll be going through how this series will proceed ahead, and apart from that, we'll also discuss as to what will we be doing to learn PCB design as a whole. So trying to understand how we'll be proceeding with designing the PCB, etc., etc. So. First off, about how we'll proceed with the series, there will be essentially two playlists you will get. One is a complete playlist on using the tool. So that whole playlist will be completely about how do you learn to use the tools that are present in Kicad. So that is one separate playlist. Apart from that, there will be another playlist which will be completely about the physics behind PCBs. Apart from that, design considerations, why you should design a PCB in a certain way. Apart from that, a lot about even the kinds of components that are available. Say for example, you get an IC. An IC can come in many different forms. It can be a BGA, it can be SMD, it can be a THT IC. So we'll discuss as to different ways in which things are manufactured, what you should be considering when you select a different type of package. Not just that, like in general, say you are sending a PCB for fabrication to a fabrication house. So what is it that you have to consider? Like, you might have certain specifications which you want to meet. And while say, even the process of selecting a fabrication house in the first place, say, how do you even select that? So there'll be a whole separate playlist for all of this. So physics and manufacturing, that will be a separate playlist altogether. So let's get back to PCB designing. Today in this video we'll be discussing about how will we proceed ahead with learning the tool that is Kicad, right? If you think about it, if you want to learn anything, if I just say, for example, you have to make a project, right? And that project is extremely exciting. Like you're intrigued by what you have to do ahead, right? So that is a lot of fun to do. Now compare that to, I give you a textbook, you go through the textbook, you understand, maybe different terms in the textbook, and then that's the way you learn something. So I personally highly prefer doing something like a project in order to learn something. Reason being, it's very simple. Once you do a project, you have a purpose. When you're reading a textbook, generally people don't have a purpose per se, and it's not that enjoyable as well. So I prefer doing things that way, and I really believe that people will learn things better if we can make it more fun to learn. So in order to do that, to learn the tool that is Kicad, we will be designing a small PCB around something called a shift register. So in this video, I'll just explain what this tiny project will be on which we'll work. It's very simple. I cannot imagine something simpler that you could work on. I mean, maybe, possibly you could, but again, it's like a base level where you can start to learn PCB design. So I've picked this to I'll make this project such that it is very easy for anyone, no matter your age. Like even if you're in school, I am sure you would be able to build something like this. Alright, so this is the whole purpose of selecting this project. Coming to what the project is, we'll be working on building a PCB around a shift register. So first off, let's go through what a shift register is. Essentially, imagine you have, say for example, you are running out of GPIO pins. And you only have to control digital signals, like you have to just control LEDs. There's nothing like, communication going on. Say like SPI, what I2C, none of that. We are just interested in switching the pins high or low. Okay, so what you can do in this case is use something called a shift register. What a shift register does is that it only requires 2 pins, but using those 2 pins, you can control more than 2 pins. That is, you could control say 8, 10 sorry, 8, 16, powers of 2 essentially. So what we do here in a shift register is we send on one of the 2 pins, that is the clock pin, you send a clock signal. So like it's a pulse train, high, low, high, low, high. And in parallel to that, we also send a signal of high, low, essentially telling that which pin is supposed to be pulled up or pulled down. So say for example, I wanted to have the states of the 8 pins I've connected to be, first 4 on and the rest 4 off. So what I'll do is I'll have my first clock signal, and as I have sent out that clock signal, I'll also on the other pin I would send a high, and then similarly I'll send 3 more and 3 more highs on the other pin, and after that I'll send 4 more clock signals and 4 lows in parallel to that. What this would do is that the first 4 pins you have, they will all be pulled up high, and the next 4 you have, they'll all be pulled down low. So essentially what you'll have done is just using 2 pins on your microcontroller or any you could literally even use a switch for this. So you don't even need a microcontroller for something like this. You just need 2 switches, that's all. So you could use a microcontroller, but this is just an example. So essentially what you've done now is just with 2 pins you have controlled 8 LEDs or 8 pins essentially, which are 8 digital pins. So this is done using something called a flip-flop. I won't get into detail what a flip-flop is, but essentially what it is that imagine you have the RAM you have on your laptop or any device you use. The smallest unit of memory is something called a flip-flop. So the circuit inside your computers or any digital device which temporarily can store information is called a flip-flop. That is all you need to know for now. You can get into detail to understand the whole circuit design of this IC itself, but I won't be going into too much detail of that. All right. Right now we'll be going through the pin description. Okay. So as you can see here, this is the IC. This is like the top view of that IC. Here you can see QA, QB, QC up to QG, even up to QH, and apart from that you have some more pins. So one is ground, other is VCC. That's simply the power supply you're having. Apart from that you have SCR, OE, RCLK, SRCLK, SRCLR. So RCLK, that is going to be, if you go down here, you would be able to understand this even better. So this is essentially the data sheet of the shift register I'm talking about. So the one we are using is called HC595, 74HC595. If you just Google this, you'll find it very easily. Coming to which pin does what, if you go down here, you have something called a function table, right? So function table essentially tells you what will happen if you say, pull up or pull down a pin, and what action would the IC take. So here if you see SCR, that is the pin that decides the data that you are putting into the IC. So the first 4 ones and the next 4 zeros, that is the data that you're going to put. So how are you going to do that? To do that, you have to pull the pin SCR high or low. That decides what the data will be. And SRCLK, that's clock for the SR flip-flops. SR flip-flops are just a type of flip-flops. Again, I'm not going into detail on that. There's a lot available online to understand that. So if you pull SCR low and you give a rising edge, so this arrow, upward arrow, tells that you're giving a rising edge. That means that first stage of the shift register goes low, other stages store the data of the previous stage respectively. Meaning, as soon as you do this, you pin the SCR pin low, giving the information that the next bit is going to be 0, and same time you give a rising edge, that is the clock pulse. That would tell the IC that the next bit of information is a 0. That's all. So if you're in the sequence, this is just one bit of that sequence. And if you do a high on that pin and give a rising edge, the next bit you are sending essentially is going to be a 1. Coming to what is SR-CLR. So SR-CLR is for clearing the SR flip-flops. So if I pull this low, so this is an active low actually. So if you want to make this function happen, so if you pull this pin low, what will happen is the shift register gets cleared. So for example, if I'm say controlling these 8 pins on the IC using my 2 pins on the device or just with switches, what will happen is if I pull this pin SR-CLR low, the information I had previously, let's say all the first 4 LEDs, all 1, that's all turned on, and the next 4 turned off, what will happen is as soon as I pin this, I pull this pin low, that information will be gone. So all the flip-flops will turn to 0 and all your LEDs are now off. That's what will happen. So this is the purpose of this pin. Coming to what RCLK is, it is for storing the data into your shift register. So for example, I gave this information to my shift register that I want the first 4 pins to be on, the next 4 pins to be off. Now it is actually expecting something to come along with that next. So it's like it's still waiting for information. So what you can do is if you just give a rising edge on RCLK, that's our clock, that would essentially tell your IC, hey, the information you have to just retain it. Okay, so once you do that, your information will stay, as in like the 4 LEDs you turned on will stay on and the next 4 LEDs you turned off will stay off. So that is what these pins do. Apart from that, there's OE, that's output enabled. So if you pull this high, what will happen is all your pins can now turn on or can now turn off. If you pull this, it's the opposite, my mistake. So if you pull this high, what will essentially happen is all your pins are disabled. You cannot now control them. If you pull it low, again, if you see a bar on any pin, that means to execute that function, that pin has to be pulled low. So to have output enabled, you have to pull it low. To actually control your pins, this pin must be low. So here you can see low, meaning that we want all of these pins to be enabled. Okay, so this is essentially the IC we'll be working along with to, we'll be designing the PCB around this IC. So you'll have LEDs, you will have a screw terminal, not exactly a screw terminal, we'll get to which terminal we are using, but you'll have a power supply, you need to step down power a little bit, and then you have to supply it to the IC, right? And from externally you'll get some input which will control these LEDs. Okay, so this is what we'll be working on. In the next video, you will understand how to make the schematic for this. So you'll understand, say, how you have this idea, okay, I want to, execute this, I want to work around a shift register. So I know I need LEDs, I know I need some sort of power regulator, and I also need some input, so I need some header pins, something like that. But it's just an idea as of now. To really put it on paper, you need to first make a schematic. So that will essentially tell you what are the connection between different things. So that's all for this video. In the next one, you'll understand this whole process as to how do you make your schematic. So I hope to see you in the next one. Bye bye.